So today, my friends, you are going to be introduced to the law of sines, an incredibly useful tool, a shortcut to enable us to be able to find anything we want about triangles pretty much all of the time. Here's the setup, and then we'll see how it works in action. So you use this method to find missing information. That could be side lengths, or that could be angle measures in a triangle. When you have a set of opposites, here's what I mean by opposites. I need to have an angle and a side length across from it. I only need one set of opposites. So if I know angle A inside A, or angle B inside B, or angle C inside C, one set of opposites is enough to make this a useful tool. Let's see how it works. So here we have a triangle. Hello, triangle. And it's our job to determine here the length of BC. Notice it's a length because it's a line segment without the segment bar on top. So it's the length of that side. Now, in terms of knowing whether law of sines is appropriate, let's see what we have. I've got angle A. I don't have, if I go directly across from it, I don't have this side length. That's actually what we're trying to find. But, look at this. I do have this angle and the side length across from it. So I've got angle C and side C. As we turn the lights back on, I did make myself a note to walk around before I record. I just forget to do it. Okay, because we have this set of opposites, angle C and side C, we can use this part of the law of sines. The sine of angle C divided by the side length C is going to be the same as the sine of the angle A divided by the side length A. We can now fill in what we know and then solve for what we don't. So we know angle C is 44.3 degrees. We know side length C is 15 centimeters. We know angle A is 27.7 degrees. And we know side A. Actually, we don't know side A. That's this length that we're trying to find. Now, what you put down here, you can leave it as little a. If you want to switch to calling it BC, doesn't make any difference. I'm going to leave it as little a for right now because I know that that's the same thing as BC. To solve these, it's always going to end up being a proportion. So cross multiply. If I cross multiply, I'm going to have a times the sine of 44.3 degrees equals 15 times the sine of 27.7 degrees. And here's the important thing. This and this, these are just numbers. They're not the prettiest numbers in the world, but they're just numbers. So to finish, I can divide both sides by this number. So the sine 44.3 degrees, divide that on both sides of the equation. A degree symbol inside there. Okay, and we're all through. So this side length that I want, because here that reduces with that, is equal to 15 times the sine of 27.7 degrees, all divided by the sine of 44.3 degrees. And at that point, I head over to a calculator. Quick check, make sure I'm in degrees. I am in degrees. So 15 times the sine of 27.7 degrees divided by the sine of 4.3 degrees ends up being about 9.98. I'm going to call it 9.98. Pay attention to the rounding instructions in whatever it is you're doing. Right now, because there were no rounding instructions, I chose the hundredths. Nothing super magical about it. Okay, so that side length BC is about 9.98, and the unit would be centimeters. So let's recap what we did. Take a look at what you have. Because I had an angle measure and the side length across from it, that's what makes the law of sines a good tool. Set up your proportion, put in what you know, so you can cross multiply and solve for what you don't. Okay, next one. I want to find AB, so let's see what we got. I have angle A and the side across from it. All right, I've got my set of opposites. This is the side I care about, AB. So that's across from angle C. But shoot, we don't have the measure of angle C. Please don't overthink it. In a triangle, I hope you remember that all of the angles add up to 180 degrees. So to get this angle measure, let's just take 180 minus 75 minus 47. So this angle over here is 58 degrees. Now we've got the information we need to set things up. So sine of angle A over side length A is equal to sine of angle C over side length C. Fill in what we know. Sine 75 degrees over 33 kilometers. And 58 degrees over, I don't know, how many kilometers. Okay, at this point, do a quick pause, solve it out, unpause when you're ready to check things. So across multiply, and then a division. Actually, let's make that go all over sine of 75 degrees. Just going to use my handheld calculator so I don't switch back and forth between screens. Okay, we should end up with a side length of about 28.97. Unit here is kilometers this time. And let's just see, does that seem reasonable? The picture's not perfectly to scale, but it should be probably something in the realm of this 30 number. So yeah, I think I'm going to buy that as being reasonable. Okay, let's go again. Here, I'd like you to do the whole thing, start to finish. So give it a quick pause here, unpause when you're ready to check things. Okay, XY is the side I'm looking for. So in this triangle, that's going to be the side lowercase z. I already have angle Z, so that's a good thing. Now this 22.1, that's measuring angle Y, and I've also got side Y. Okay, we can set things up here. Sine of Y over Y equals sine of Z over Z. Notice we switched letters, doesn't make any difference. Same relationship still holds. Fill in what we know. For the 12 miles is the sine of the 69.9 degrees over the, we don't know how many miles. Okay, then cross multiply. And then a division to finish up. So there are some patterns here that once you pick up on them can save you a little time, but I'll leave those for you to find out for yourself. Right. So that's exact, but let's get a decimal approximation. Now just ballparking it here. Again, the picture is not perfectly to scale probably, but I should get a number that's bigger than 12. Looks to me like it's going to be at least double, probably somewhere between double and triple, maybe even more. Who knows? Let's see. So 12 sine 69.9 degrees. Sine 22.1 degrees. Okay, I ended up with about a 29.95, and my unit again here is miles. So yeah, somewhere between double and triple. So the big takeaway from your law of sines, if you've got an angle and the side across it, you can use the law of sines relationship to solve for that other missing side.